Hi, now I am going to teach you the double field revolving theory. Okay, so the double field revolving theory, it is in single phase induction motor. So what happens in single phase induction motor is that the single phase induction motor is not self starting. So we have to prove that with a standard derivations that yes, the single phase induction motor does not have a produce a torque and starting. So how to prove that? We know that in single phase induction motor we give a single phase supply, and when we give the single phase supply it produces single phase flux. So as per this double field revolving theory, what it says that the total flux what it has been produced, this total flux is divided into two, equally divided into two, that is one is 1 phi m by 2, another one is phi m by 2. So what is phi m by 2? We know that single phase flux is like this. Okay, so now it is the single flux. Now the whole we cannot say what is the value at this instant, this instant, this instant. So we can only consider the maximum value. So this maximum value is phi m. So that value is divided, we are dividing into two, that is one is phi m by 2, another one is phi m by 2. And we assume that it is just we think that the flux, due to this flux the torque is produced, due to this flux the torque is produced, and both the torques will be in opposite direction, because we assume that one flux is rotating in clockwise and another one is rotating in an anti-clockwise direction, and this produce the forward torque and this produce the backward torque, and both will be same magnitude but opposite in direction and cancels each other, so that the resultant torque will be zero. Hence the single phase induction motor does not rotate. So this is what we are going to conclude in double field revolving theory. Okay, so it is, so here we say the total flux, that is the phi m, is divided into two, phi m by 2 and phi m by 2. One is in clockwise plus another one is in anti-clockwise. Okay, so when it start rotates, let us find out the total amount of every instant what is the total flux, and also how the final shape becomes. Okay, so when these two vectors, that is phi m by 2 and minus phi m by 2 both, so let's say we start from this instant. Okay, so now since the both the fluxes are in the same direction and parallel to each other, now this is the first instant. When it is in parallel to each other, when we find out the resultant, so what could be the resultant here? So simply we will be adding this vector addition, so hence you get the answer phi m. Now at first time the value we get is, so the first instant we get the value phi m. Now when this is rotating in this direction and this vector rotating in this direction, now how it will look? So in second time you can say that one vector is here and another vector is here, and this is a reference line. Now here it makes an angle of theta, this here it makes an angle of minus theta, and this is phi m by 2 and this is phi m by 2, this is plus phi m by 2 minus phi m by 2. Now at this situation, now we can find out the resultant flux. So what will be the resultant flux value? Let us calculate. So in the second position, so here it as I told, here plus theta and here we have another theta. Okay, now when we find out the resultant, what is the answer we get? So it is two vector, both are phi m by 2, so 2 phi m by 2 cos theta by 2. So now the final answer is phi m cos theta. So this is phi m. In first instant the resultant flux was phi m, and second time this is the resultant flux. Now what will happen in third time? Third position, this will be rotating further, rotate like this direction, and this will rotate in further next direction. So now what will happen? At one particular point both the vectors will be like this, that is opposite direction, opposite to each other. Now what would be the resultant? Both are same and opposite to each other. So now your answer will become 0. That is, there will not be any resultant flux. That is, the resultant flux will be 0. So this is the second position and this is the third position. Okay. So here we write third position is 0. And what would be the fourth position now? So in the fourth position, further it rotates. Now the vector will be like this. Okay, this is phi m by 2, then phi m by 2 minus phi m. One is plus, one is rotating clockwise, another one is rotating in anti-clockwise. Now it looks like a same second position. So here angles are coming. Now you have to find out the resultant. Now this here also the resultant comes out to be phi m cos theta. But what is the difference? Before it was this side, now this side. So we have to consider this is minus. So in the fourth position we get minus phi m cos theta. And now what is the next position? In next position this will come closer, this will come closer, then it becomes like a first position like this. Now what would be the resultant? The resultant same as the before, that is phi m, like the first one. But this, since it is before it was this direction, now it is in this direction, so it will be minus phi m. So in the fifth position we get it is minus phi m. After that minus phi m, what will happen here? So this one further, this will start rotate here and it will start rotate here. Now again it becomes the same angle. It will be same. See here, only the thing is this will go here, this will come here. Okay, so now it is the same position and same minus phi m cos theta. So the sixth one, it will be minus phi m cos theta. And now after that again this will go and this will comes in the straight position. Okay, now let me erase. So now in different positions, first it was phi m, the next it was phi m cos theta, and next it was 0, and next it was minus phi m cos theta, the next it was minus phi m, then again minus phi m cos theta, then 0, then it goes to positive, then from 0 it goes to plus phi m cos theta, then it goes to phi m plus phi m cos theta, then phi m, like this. So when we try to combine this all the instants with respect to angle and the value, so let's say this is the theta value and let's say this is plus phi m, let's say this is minus phi m. So when the theta at the time of starting, when there is no angle, both are parallel, so it was plus phi m. It will be phi m, then phi m cos theta. So when we substitute the angle different value, it's come like this and it goes to 0, 0. Then minus cos theta for different value, the value will be in negative, it goes to minus phi m. And then again at minus phi m cos theta for different value, then it goes to 0. Then plus phi m for different values goes, then it goes to. So from this we can clearly understand, we say that the single flux divided into two components and both are rotating in opposite direction. So when we find out the flux produced by that both the flux which are rotating in opposite direction, when we find out the resultant, it comes out to be single phase. So we can say that yes, why the single phase induction motor is not rotating? Because the single flux is divided into two half, phi m by 2, phi m by 2. Both are rotating in opposite direction. Positive direction produce a positive torque Tf, a negative direction flux produce a backward torque Tb, and both the magnitudes are same, equal, and get cancels each other, and hence the single phase induction motor does not rotate and it is not a self-starting machine. Now let us see what is the values of flux, because it is having 2 torque. So if it is having 2 torque means we have to find, so it will be having 2 different slip. So let us find out the slip at the forward torque and slip for the backward torque also. Okay. So we know the formula for slip. Slip S equal to Ns minus Nr by Ns. This is a forward slip, general slip. In this, From this, when we find out the rotor speed, we know that rotor speed is equal to nr equal to ns into 1 minus s. Now, when we find this is a forward slip, when we find out the backward slip, what happens? Ns minus, now the rotor is rotating in opposite direction, so this will be minus nr again, so by ns. So you get ns plus nr by ns. Now when we substitute ns by ns in the place, plus nr is equal to ns into 1 minus s. So when we substitute, we get the backward slip, that is equal to, so when we write ns by ns plus ns into 1 minus s by ns, so this will be 1 plus 1 minus s, that is backward slip equal to 2 minus s. Okay, so the forward slip is simply s, that is ns minus nr. This is simply s, but the backward slip is 2 minus s, so s and 2 minus s.